Hey, welcome back to Pythagorean Identities. And I'm going to start off with a very nice little proof here. Lots of misery it looks like, but at least the right side looks pretty good. It says it's supposed to all equal 2. Let's see if we can prove that. First of all, I like to convert everything to sines and cosines, but it already is all sines and cosines. So what am I going to do? Well, it's messy, but it's actually pretty straightforward. What I'm going to do is I'm going to expand out these brackets. So we've got this guy times itself. And let's see if we can squeeze it in here. On the next part of this, we got sine plus cos times itself. Okay, so lots of expanding out. Okay, and there's not much we can do on the right side. It says it equals 2. Let's see if it does. So I'm going to just FOIL this stuff all out. I got a sine times a sine, so I got sine squared. Then I got a sine times a negative cos, but I also have, so this guy here, and then I also have negative cos times a sine. So there's actually going to be 2 of these. So they're both negative, so negative 2 of these sine theta cos thetas. And then I have a negative cos times a negative cos, so that's a positive cos squared. All right, so there's the first one done. Now I'm going to FOIL out this one. Well, I got sine times sine, so I got a sine squared. And then I got a sine times a cos, and also a cos times sine, but this time they're both positive, so I got 2 of those. All right. And then I got a cos times a cos, so that is a cos squared. Well, look at this. I got a negative 2 sine times cos, and I got a positive 2 sine times cos. These guys, they cancel with each other. That's perfect. Now here's what's left. I got sine squared plus cos squared. You know, that to me is my favorite all-time identity, because that equals 1. Then I got plus sine squared plus cos squared. Seems to me that also equals 1. And look at this. It equals 2. So the left side equals the right side. Nothing to it. So we are ready to move on to bigger and scarier proofs. All right, let's clear the screen. And here we go. We're going to try and prove that secant theta, all divided by sine theta, minus sine theta divided by cosine theta. Supposedly this equals cotangent. All right, well, let's see if we can prove it. All right, first things first. The right side is pretty simple. If I convert this to sines and cosines, then this would just be cos theta over sine theta. So that's what the right side boils down to. And the real work is the left side. What do I do with this mess? Well, let's see. Secant is the same thing as 1 over cos. So let's do that. And then they got a sine theta on the bottom. And then over here, I just got sine over cos. Okay, so we want to leave it with sines and coses. There's not much I can do here except I would like to create a common denominator, and I'd also like to clean up this complex fraction. Well, the good news is I think I'm going to be doing 2 steps in one here. The common denominator would be to multiply the top and bottom here by cosine, and at the same time that cleans up the top, so that's kind of nice. Over here I'm going to multiply top and bottom by sine, and that way I create a common denominator, so I can combine my 2 fractions into one. So what do I have? Well, I got my common denominator of sine theta times cos theta on the bottom. Over here, cosine times 1 over cos would be a 1. Then I got minus, and then I got sine squared. right? sine times sine. And now I look at it and I go 1 minus sine squared. I know I've seen that somewhere before. In fact, I think it is a rearrangement of my favorite identity. Yes, I think it is. If I subtracted sine squared to the other side, then I'd have 1 minus sine squared, which is actually the same thing as cos squared. Now look at this. I think we are in a position that we can cancel one of these cos squareds on the top with a cos squared on the bottom. And wouldn't you know it, I'm left with a cos theta over sine theta. And I can't, well, I'm going to squeeze it in here. But there it is. And you know what? That is equal to the right side. So I did it. Another successful proof. Well, that's awesome. And that's where I'm going to stop. So we're going to catch you later.